Let's now dive into the IV calibration curve. As mentioned earlier, the IV curve is part of the TSPL configuration. If we open this drop-down menu in the Advanced tool, we can individually control each process that has been run during the TSPL configuration. So let's have a look at the IV calibration curve first. So during this process, we want to check the response of the resistances of the heater for the tip and the heater for the reader sensor, so that we know which voltage we need to apply to achieve a certain temperature. And this is crucial when we need to do thermal scanning probe lithography, but also when we need to perform the reading of our patterns. So as you can see here, we have two curves because we have two resistances, and these two curves are different because these are two regions of the cantilevers which are differently doped. The material is silicon, so the behavior of this curve will resemble that of an IV response of a doped semiconductor. So in general, since we have different doping level, we should not expect these two curves to be matching, and they should be pretty much always look like this, because in case the material is not ruined, this is a typical behavior of doped semiconductors. And as mentioned in the previous videos, if we press on our question mark, we will go to the user manual, which will explain our IV curve. In this case, a useful explanation can be, for example, the understanding of the behavior of this specific curve. So why do we have these three regions? One is the ohmic region. When we start heating up the semiconductor, we will have an ohmic response of the material. Then as the temperature keeps on increasing, the phonon scattering will hinder the electrical conductivity of the material, and then finally, as we reach a threshold temperature, we will start seeing an intrinsic behavior of the semiconductor. And you will also see that there are some rounded points which are called the knee points that are used for the calibration of the nanophaser, so to calculate the temperature of the heaters at a given applied voltage, which are always reported in our IV curves. So let's go back to our tool. You can press this and we will go back to exactly where we were. So this curve is very important because it helps us understanding immediately. You see how short it takes to run this test. So 1, 2, 3, 4, 5, 6 seconds. We can easily see if our cantilever are at least working fine in terms of resistances, and also if the electrical connection of our cantilever holder to the machine is good. So if we didn't place correctly the cantilever holder to the machine, then we will not see a good electrical response because the electrical connection is not good. So these are fundamental information that we need to know when starting using the nanophaser, and in general we can also get other useful information like which voltage do we need to apply to reach a certain temperature. We can see, for example, we want to know the voltage that we need to apply to achieve 1200 Celsius. In the writer channel, we write down 1200, we press enter, and we see it's 7.9. You can also see that from this curve, at a certain point we stop collecting the data at around 1000 Celsius, because we don't want every time we run this test to go through temperature that may damage the material, the cantilever, because we're talking about silicon, so we don't really want to heat it up to 1400 Celsius every time. So at some point we will extrapolate the behavior of these two resistances, and this approximation is quite good. You can also see in the applied voltage and stopping temperature menu which are the temperature at which we stop the calibration. And if you're really interested in getting the most precise value of the temperature given a certain applied voltage above these two temperatures for reader and writer, which are preset values, you can always modify them. But in order to preserve as long as possible these two resistances, we recommend to keep these temperatures as they are, and they will be always at 900 and 1050 whenever you turn on the NanoPhraser software. So yeah, this curve is quite important. It can give you very immediate feedback if the cantilever is in good status or not, and if you place it well inside the NanoPhraser, as well as also important information regarding the voltage that you need to apply to reach a certain temperature in the heater of the chip or the heater for the reader sensor.